Hello friends, this is my setup in my bus, my battery system, two custom EV batteries, about 4.5 kilowatt hours, these two bus bars. Above I have solar charge controller, and down here I have an inverter. This is the power tool, and this is another power tool using a different shunt. And then this is a Victron smart shunt, which I'm comparing. Now, these two are on the cold side on the negative lead, and this one's on the hot side on the positive lead. And there's a switch down there that you can switch between the two, but there is future work going on with this tester board to create an automatic switch so that you don't have to set it for either or. It'll just know what it is. And these are a few different options. I have some relays. The full bridge rectifiers work, but there's a significant voltage drop, which I need for the ADC on the power tool to be accurate. These are versions with MOSFETs. All of these circuits have their issues, and still trying to wrap my head around it a little bit, so I might be getting new prototypes of these soon without this circuit, but I'm a little uncomfortable with the switch that's on there and might move to a jumper situation just to get current prototypes out, because these work really great. And the only difference between these two, which have been in here for the past 6 months plus, and the future ones, is the IC is going from the INA 237 to the INA 238, which has a few more computational features on it, and it goes from 12-bit to 16-bit for accuracy purposes. I'll take a quick look at the laptop, and we can see the comparison between the hot side, the cold side, and the Victron. The Victron is actually coming in through this power tool. I'm getting the data from the Victron so I can compare and contrast this data with everything, and we can do graphs. And here's another graph. You can see right there I've ran the microwave, and I can run the microwave again, and we can see calculated watts 1700, about 1700. And these, there's still just tweaks to how this information comes in and is laid out when the user gets it and sets it up. Here is a version of the power tool with an enclosure on it. Sorry for the glare, I am still working on it. This is a multicolor print from a Bamboo Lab A1 Mini with the AMS light. I'm not sure how I feel about this yet, and I'm weighing using labels. And then I've also been looking into UV flatbed printers as well, but those are a pretty big investment. But I think a printable vinyl with a Silhouette or a Cricut machine would probably do well to cut this out. And then also I have clear PETG used for the LEDs that are in there as well. And there's also a boot button and then a hole for the reset. On the inside, you can see that the Flip C3 is just socketed, and it has the power transfer to the onboard buck converter that's on here, 5 volts, 2 amps, and tolerant up to 60 volts. I'm still working on making direct connecting to 50 volts plus less destructive, but it's noted in my documentation right now that the Flip C3s are actually derated for 50 volts when connecting live, but can go up to 60 volts if, say, you drain your battery below 50, and then it's like a 48 volt battery, it goes up to about 58 volts, and it should be totally good to go. And then on here is just some basic circuitry. We have stemma QT / quick connectors for I2C. The IC is actually under here, directed at the shunt, so it can possibly pick up some of the latent heat if this thing starts to overheat. And we're getting accurate results with this. Also, here's the SHT C3 for environmental. And then here's a dip switch for the I2C, so multiple of these modules can actually daisy chain together. So you could have this one with the Flip C3 on it, and then you could have another one without for another purpose, let's say a different leg or input versus output. You could just use a standard I2C cable to the next board, and even intermingle voltages. I wanted to go a little bit more over the software, the ESPHome configuration. This is just a dashboard that I created to kind of compare the three shunts that I have. Here's the hot side shunt, here's the cold side, and here's the Victron. You can see some discrepancies here. This is just from testing various configuration settings, things like shunt resistance, ADC timing, averaging, and whatnot, and that's just kind of tweaks that I need to do to dial this really in. But this cold side inverter that I've been testing here, this specifically daily energy, like Coulomb counting, watt hours, 208, 194 is pretty accurate comparing the cold side to the Victron specifically, which I think should be kind of like our gold standard. If we go into the actual device for, let's say, the hot side here, we can see that we have the PwrTool, the MOSFET right here, which is set up as a fan at the moment. Here's the RGB LED that's on the Flip C3 and the status LED that's on the Flip C3. And we have all our data here, pretty standard stuff. I've done some calculations in ESPHome to get something that's like probably more standard for like a user who's going to use this out of the box. You can do a zero offset. You can also invert the data, so you can either count up or count down depending on how you want your data to look. Just a standard reset, what your firmware is. We even, on every Flip C3 device, we include the factory default reset, which is disabled by default. And then just some diagnostic information, the Flip C3 temperature, Wi-Fi signal, and then the current offset and the power offset, just to have those in there to see what you can do with them. And then obviously all of this can go and be used in ESPHome, which I'd like to go over some of like just like the basics of how I've modularized our setup for Flip C3 and Flip C3 based devices, so that we have like a standardized firmware to be loaded on these devices, and then kind of like packages and modular systems that the users can kind of just like pick and choose what they want in their use case. So here we have the Flip C3. Here's the working PwrTool 500 YAML. We have the Flip C3, Wi-Fi, dashboard import, the SHTC3, the LEDs, and then here's some commented out stuff that you can just kind of like uncomment and put back in really easily, including the switch panel that we're working on. So that could be daisy chained over I2C. You can actually see the 237. I had my friend Izzy start an ESPHome component for the INE237. And then I've been doing a lot of testing on that for the past 6 months until about a month and a half ago. I actually found out that somebody was actually working on the whole library of INA23X devices, and that's about to be pulled back into the main ESPHome as a default component. So we're actually pulling in an external component from that user on GitHub, and I've been doing more of my recent testing with that software, and we're still getting great results. Unfortunately, Izzy wasn't able to finish the software, so luckily checked GitHub again, and it's here. Again, you can see I'm kind of just like making modular components that can be reused. There's variable systems that can be used. You can actually see in this one, under this commented one, we can actually pass through like the address, the ID, and the interval on this one. And you can actually copy those to make multiple copies of the switch or the PwrTool, and then you would duplicate that with a secondary address, and you wouldn't have to physically copy this whole block of text underneath itself. You just have a single line and you declare the necessary inputs, and it'll do the same thing that it did with the base PwrTool, and then again for the other address. I'm also trying to think about additional like consumer add-ons that people might want to use, something that might be like important for users to use within, let's say in my case, a bus, or just like an off-grid system in general. Here's a YAML that you can just put in and use it to connect to a daily BMS. Very much like the Victron connection that I showed you earlier, that could be another modular package. You're going to say, hey, I want to connect my daily BMS and have that information pulled in through the PwrTool over a serial connection. And then you have, like, instead of getting an extra flip C3, you just buy a connector, 2 wires. I'm also doing some Bluetooth stuff. Here's one that I'm working on that interacts with some newer of the Chinese diesel heater controllers over BLE. This is based on some work on GitHub, and I'm just trying to organize it a little bit better. It's a really basic input-output set. You have all the Bluetooth characteristics here and the values that you need, and it's really more about user experience and how that comes back into Home Assistant and is shown on the front end. And then in the future, we'd like to do some maybe custom front-end components to show things in more unique ways and kind of lean on my history as a UX designer. And I think a lot of this stuff is just UX for like the developer sides. I'm not much of a developer, but I can easily navigate myself around YAML configuration in ESPHome. And I think it's necessary for a good amount of people to have some better entry, less friction to enter from getting this device in their hands to and using it just as it is out of the box, to moving towards, hey, I'm going to import this into ESPHome and then try to mess around with some of the code a little bit. I think improving that user experience alongside the out-of-the-box experience is really going to be like super helpful and super valuable to my users. And then adding these additional modular components very simply to expand the feature set of the PwrTool is just super valuable. As kind of like an end, I did talk about this circuit and potential future prototypes. What I'd like to do, as I mentioned before, is maybe to move forward faster. Since the polarity correction circuit doesn't really like affect what's going on in here for the most part, I think it'd be wise to do a pre-production or like early beta run with just like a manual switch for the polarity, to send that out to influencers and stuff for them to review. And then as we complete our campaign or get through our campaign, we can start finalizing the hardware. I think at this point it's really just like passives and components. I'd love to do an engineering review with somebody to see where like the final tweaks can kind of happen. And then maybe we can also talk about what the best option for this is, because I'm still slightly having trouble wrapping my head around this. All of these are great solutions, and just one thing is wrong in each of them, and I'm still trying to find solutions to fix these, and these are hard to simulate in online simulators. So that's about it. Bye!